If you log in at around 1:30, then you get full 15 minutes. If you log in at 2, you only have 20 minutes to finish your quiz. So whenever the quiz will be active from 1:30 or recitation time till 2:20 or recitation time next week. So we are not going to meet here next week. Are you with me? Just as a taken. Now what happens in this reaction? What is that? In presence of concentrated acid, this OH group picks up a proton because acid acts as a source of proton. Acid by default is a proton donor. So this grabs a proton from HCl, it grabs a proton, forms water. That's pretty much water which is connected to that carbon. Now this is a very good leaving group. It can just be kicked off from this carbon. This bond is now so fragile that this can come off. And that's what happens. So that comes off as water and you're forming water in the solution. This forms water but leaves behind, after this bond is cleared and those electrons being pushed towards oxygen, that leaves behind a positive charge on that carbon, and carbon with a positive charge is known as a carbocation, isn't it? That's a carbocation. Now, once this proton is being grabbed from HCl, remember you are eliminating a Cl minus. You are forming a Cl minus in this reaction. This is grabbing the proton, that bond is being cleaved, and those electrons being pushed to Cl, forming Cl minus. Now, you have a positive charge, you have a negative charge. Obviously, this is going to attack that. And whenever you're showing this attack should always be from a negative charge species to a positive charge species. You should always push electrons from a negative charge to a positive charge. Never the other way around. Because positive cannot donate electrons. Negative can donate electrons. So that's what happens. And this donates electrons. It attacks that positive charge to form this. It's as simple as that. All you need is that HCl, which acts as a proton source and also a Cl minus source. This also generates H plus and Cl minus, and that's all we need for this reaction to occur. Are you with me in that? So it's as simple as drawn, honestly. The reaction is very, very straightforward. Now, what you do here is, if you read through the procedure, I'm sure you have your pre-lab done. So when you're doing the pre-lab, you'll go through the procedure, right? You write on the procedure. So what it asks is, you take this, and in a centrifuge tube, and you cap it and tilt it, like shake it vigorously, shake it to form the product. But when you're shaking it, please be gentle. Now when capping the centrifuge tube at any point in the lab, consider this as a pressurized vessel. Even after workup, during the workup. Has anybody written down your pre-lab procedure? Did you write down your procedure? So, okay, good. I was just asking, there's no reason. If your lab is on Friday, then obviously your lab is on Thursday, then obviously you're going to wait probably, but it's okay. So the reason why I was asking so that we can answer this question, that was the purpose of that question there. So when you're capping this, when you're capping the centrifuge tube, when you add sodium bicarbonate or anything like that into this reaction mixture and shake it, at some point you're going to add sodium bicarbonate to neutralize the excess of acid. You have excess of acid, you need to get rid of this from the reaction, you add sodium bicarbonate and shake it. Now, whenever you're shaking this, be very careful. Because as I said, sodium bicarbonate releases carbon dioxide gas. And when you're capping the centrifuge tube, that's a small thing. You added sodium bicarbonate, which is releasing carbon dioxide in that small space. If the space is not sufficient and you did not open the cap to release the gas, obviously it has to find space. It will blow the cap off and come out. Because you're not ventilating it. So when you're shaking this, either gentle, open the cap, let the carbon dioxide come out, cap it back again, shake it back again gently, again release the pressure, and then cap it back again. So please be very gentle with that shake. Don't shake, vigorously shake it and not release the gas. If you don't release it, it will come out of. The cap will just pop out. And that is fun to watch as long as it is not hitting somebody in the lab, isn't it? We don't know. Can we control that? We never know. So we don't want to do that. Trust me, I don't want to do that. So, when removing the centrifuge cap, be careful and point, this is one important point, point the opening of the tube away from you towards the back of the head, not towards anybody else. Okay, we can take that, we can deal that outside the lab, not in the lab with opening the caps into somebody's faces. No, okay, don't do that. So let's be careful. This is a very, very important point. So please remember this in the experiment and please follow this. It's a very, very simple point, but this happens a lot. Now, which layer is what? Again, remember the densities? There is In the first experiment, there were some solvents and their densities listed, if you recall in your lab manual. In the lab manual, there is a page where there are solvents and the densities listed. So please look back to those densities and to identify which one is your bottom layer and which one is the top layer. When you're separating, remember, it is not always aqueous layer, it's always the bottom layer. So just make sure you know the densities before you figure out which layer is what. In this lab, the organic layer will be the top layer. Okay, again, the aqueous layer is the lower layer. Usually this is the case, except for a few organic solvents when this is reversed. But for this lab at least, the organic layer is the top layer, and usually our organic compounds are in the top layer, isn't it, in the organic solvent. So you should know what to collect and what to discard. Label your centrifuge tubes, label your tubes appropriately. Was the last lab easy? Did you label your tubes with extractions and everything? Was it relatively easy? Was it? Or kind of confusion, or how was that? It was confusing, little? No? It was crystal clear? It was fine? Okay, as long as you label, the same thing here. So label your organic layer and the aqueous layer. You can always test by dropping a drop of water and seeing which layer goes where. Of course you can do that. Now save all the layers until you're sure you have your product. That is one other tip, a very, very important tip. Do not discard just because you want to. Sometimes it happens, oh, I'm done with this, let's wash it off and clean it. Now sometimes you might have saved the wrong layer. You might all the way think, oh, I had the organic layer, but something happens and then you lost, okay, probably this is the organic layer, but probably you discarded the organic layer and then have the aqueous layer. What are we going to do with the aqueous layer? So just be patient, you can wash them all off at the end of the lab. Do not discard anything during the lab. That is something we do in the research lab too. In the research lab, when we are doing these experiments, we hang on to everything. The hood is a mess because every test tube is saved on. Because we never know. We might think that this is the product, but that might not be the product. And it happens a lot in organic chemistry. So just save them. At the end, when you're done, you can dump everything out, wash everything out, and walk out of the lab. It doesn't take that long. So, pretty much that's all for that lab. There's nothing much to talk about because it's a very simple experiment. Again, safety, handle causes sulfuric acid as its corrosive agent. This is for lab 5. We are done with lab 4. Again, go back. This is done. Finish the lab 4. That's done. So we are moving on to lab 5, which is carbonyl reactions. Reactions test for carbonyl compounds. And this lab 5 deals with some carcinogenic and also some strong acids. So I'm talking about safety for the lab 5 first, and then we'll deal with the reactions, okay? In lab 5, some of the reagents you are going to use contains concentrated sulfuric acid. No matter whether it's sulfuric acid or HCl or any other acid, as long as they are concentrated, they are hazardous, period. So since you're handling concentrated sulfuric acid, it is just as a corrosive reagent, any acid is, and can cause severe chemical burns. HCl does the same thing. So if something falls, by chance if it falls on your skin, just go to the nearest tap, wash it off. That's all. And it'll be fine. It will have a little burning sensation, but trust me, it is not going to make a hole into it or anything. Just it is fine sometimes, but just be careful. Now, there is chromic acid. This is something which you have to be very careful about. Chromic acid is a carcinogenic agent. It is proven. Have you watched this movie? Julia Roberts movie. What is that? It's right there, but I'm not able to think of it. Where she works as a volunteer. She's the lawyer's assistant, and what is that movie? Erin Brockovich. Have you watched Erin Brockovich? It's a relatively old movie. If you haven't, you should watch it. If you're not a fan of Julia Roberts, I can't help you, but it is not that I was a fan of Julia Roberts. It's all about chemistry. It's all about the chromium chemistry. You'll enjoy that movie. You'll enjoy that movie, and that movie is based on real incidents which occurred in the United States. It is a real story. It happened to people. People suffered that way, and the company had to pay millions of dollars, which cannot get the lives back from the people who are dead already or suffering from that. But at least it's some compensation rather than just being ignored. So that is when this has become a big issue. Until then, people were kind of getting into those furnaces and cleaning the chromic acid. Can you believe that? And for that reason, I'll give you one more example. This is the reason why we say handle chemicals very carefully. Right now, a chemical is prescribed or chemical is said to be safe to handle until it is proven otherwise few years later. Down the lane, somebody will discover that this chemical which is considered safe now is hazardous or carcinogenic or whatever it is. Because I had a professor when I was in grad school. If you're up for a story, shall I? Are you? Or you just want to finish the recitation and walk out of the lab? I'll keep it short. Since I started this topic anyway. So he used to work with benzene, and when they used to like literally wash hands with benzene. That's how they used to work. You know, benzene is carcinogenic now, isn't it? Benzene is highly toxic and highly carcinogenic. That wasn't known at the time when he was doing his PhD. I mean, then it was safe. It was considered a safe chemical. Later, a few years later, when he finished and he was a faculty and he was a research, he was an assistant professor and then became a professor and then a distinguished professor and everything, university distinguished professor and everything. At that point, it was discovered that benzene is highly carcinogenic and is a regulated chemical. But by the time he already spent quite some time with benzene, and unfortunately, sometimes they get unnoticed in your body, but he suffered from cancer and he passed away when I was doing my PhD with him. He was a very nice faculty to have it. I really enjoyed his classes. He was so fun to be around, you know. And but he died of cancer because he was exposed to benzene for a longer period of time and it was not known at that point. So when we say you have to be careful with these chemicals, you have to be careful with these chemicals. Please be very careful with these chemicals when we say that, and we stress that so much. So chromic acid is highly carcinogenic, and you do not dispose chromic acid into the non-halogenated waste or any other. There is a specific waste container for chromic acid, because we need to dispose this chromic acid waste separately. There is a separate process for this which is expensive. So when our department does this chromic acid waste, we have to pay many high bucks to get it disposed of. So please do not use this reagent more than what is needed, just for all of us. It is environment hazard, isn't it? We all have to keep our planet safe. So just be careful. Do not test this. Do not use it more than what needs to be used. Do your tests. Of course you do your tests, but something which you have to keep in mind. Now, in case of any spill with concentrated acid on yourself, immediately wash the affected area with copious amount of water. I have said this many times. And contact your TA. Of course, TA will be walking around and they know that somebody had some accident or something. So they'll take care of you. Please let your TA know. Now again, I'm going to say my TAs, tell my TAs this week that anybody who is not following the safety precautions, points will be deducted, just to ensure that you are following them. This is just a scary. And if it comes down to that, we will have to take the 15% points. But yeah, I'm sure I've scared you enough now. Okay. So with all the stories I told you. Now, let's get to the chromic acid test. Now, you're going to do with your unknowns, you're going to do some knowns, of course, always. Whenever we do any test, we always do on the knowns, and then we are given some unknowns, and then we are going to test it, right? So with your knowns, you're going to do this chromic acid test. You're going to do the chromic acid test with your unknowns as well. Now, what is this chromic acid test? Remember, chromic acid is carcinogenic. You're not going to dispose it off into the regular waste. There's a separate chromic acid waste container. You're going to dispose this chromic acid waste into it. Did I make myself clear? Clear enough? Say yeah, too many times. You can say that. Now, this is a test to determine if an unknown sample has an aldehyde functional group. This is very specific for that aldehyde functional group. Okay? So whether the given molecule is an aldehyde or not, do a chromic acid test. If you get a positive test for it, we'll see what a positive and what a negative test is. If you have a positive test, it tells you there is an aldehyde. If you have a negative test, it tells you that you do not have an aldehyde. If you do not have an aldehyde, then you have a series of functional groups you can have. You can have ketones, you can have any other functional groups like alcohols, other functional groups you can have. But at least it rules out the possibility of an aldehyde being your unknown. Are you with me so far? So, whether or not you have aldehyde, how do you identify? Chromic acid test tells you that. So, it does many other things, but for our lab, we'll keep it simple. Now, what happens in this? Again, chromic acid test is also a good test for alcohols, for primary and secondary alcohols, apart from aldehydes. So, whenever you have a secondary alcohol, this is a secondary alcohol because that carbon, that OH is attached to a carbon which is attached to two other carbons. So, that is a secondary alcohol, and this is your chromic acid, H2CrO4. H2CrO4, that's your chromic acid. So what it basically does is, this alcohol kind of, if you look into the product, after the series of reactions, this alcohol is converted into, can anybody tell me what is this functional group? That's a ketone. Thank you. Perfect. That's a ketone. So the secondary alcohol is oxidized to ketone. It is oxidized to a ketone. Okay. This is what happens in this with this chromic acid. Now, what is the significance of this? Chromic acid, when you start with H2CrO4, the chromium is in +6 oxidation state. But after this reaction occurs and you're converting this alcohol or oxidizing this alcohol into the corresponding ketone, the chromic acid is reduced. The chromic acid, this is oxidized, the alcohol is oxidized, chromic acid is reduced, right? And there is color change associated with this reaction. If not, how would I know what is chromium 6 and what is chromium 3? How do you think we would know that? There's a color change. You see very distinctly to start with and to end after this reaction occurs. And that is how we test them. That is how we identify positive test or negative test. Now this can also happen with aldehydes. As I said, we said this is used to identify an aldehyde functional group. So aldehyde also gets oxidized. When I say also, I didn't mean that it's oxidized to ketone, but aldehyde gets oxidized to carboxylic acid. And in this process, chromic acid, which is +6, remember chromic acid is +6, it is reduced to chromic acid +3, which has a very distinct blue-green color. You will love this color. If you're a person with all this, looking at all these colors, Carbonyl lab is amazing for all those color reactions. So you will see that. Now, how do we get chromic acid? You take this potassium dichromate, K2Cr2O7. This potassium dichromate, when you dissolve it in H2SO4, I told you you're dealing with H2SO4. Where are you dealing with H2SO4? Right there. That's your H2SO4. So when you take K2Cr2O7, potassium dichromate, and dissolve that in H2SO4, add H2SO4 to that, you are forming chromic acid. And this chromic acid is what you take, add to your aldehyde. If you have an aldehyde, the aldehyde will be oxidized to the carboxylic acid. In this process, chromic acid is reduced and you'll see this blue-green color. And look at that. Look at that color. This is a negative test. This is the color of chromic acid. Chromic acid itself is that reddish-brown color. When you see that chromic acid, it is that color. So if there is no reaction occurring, then that's a negative test. The chromic acid is remaining as it is. But if the reaction is happening, then you see that test. That's a positive test. If you see a positive test, that tells you there is an aldehyde. If there is no aldehyde, then there is no positive test. So far with me? Look at that. That is blue-green color. I mean, this is how it looks like. This is your chromic acid. Positive test would look at something like that, the color change. Look at that. So tertiary alcohols do not give this test. Primary alcohols give that test. Secondary alcohols, this is a positive test. This is a positive test. This is a positive test. And this is a positive test with aldehyde. If you shake that, you will see this blue-green color. So again, a positive test, and that's a precipitate. This is the same thing as this. For a second, I thought it was chromic acid. But no, that's the same thing. That's a test tube zoomed in. So this is what we are looking for, an aldehyde, which looks something like this. If you see some colors like this, no clear solution. If it is a clear solution, the reaction is not occurring. But if you see a precipitate, there is reaction occurring, and that is considered as a positive test. And if you have a positive test, it means that there is aldehyde in your molecule. Done? So we knocked out one functional group, aldehyde, by chromic acid test. Now what other tests will give us more information? Now why is this test for aldehydes and not for ketones as well? Why do aldehydes get oxidized to carboxylic acids? What if I had ketone here? Say this was an R. Because if you have R here, then that makes this a ketone, isn't it? So why don't ketones undergo this reaction? What do you think? Think about it. The next reaction is Benedict's test. Benedict's test. The primary function of this was to identify reducing sugars or non-reducing sugars. But now we are not using to identify sugars at all. We are trying to identify whether a given aldehyde is aliphatic or aromatic. Remember that benzene ring? Aldehyde is attached to a benzene ring, it is aromatic. aldehyde attached to any other ring like cyclohexane or something like that, it is aliphatic. So we identified whether a given carbonyl is aldehyde or not using the previous chromic acid test. Now we are trying to identify whether the aldehyde is aliphatic or aromatic. So let's go ahead. So if it is an aliphatic aldehyde, that is aldehyde attached to any other ring system except benzene for now. So any other ring system, what is this Bendix test? That is your copper sulfate. That is your aqueous copper sulfate, which is blue color. Now if it is an aliphatic aldehyde, again this aldehyde gets oxidized into carboxylic acid. Now if this is getting oxidized, your copper is getting reduced. So copper plus 2 goes to copper plus 1. And copper plus 1 is red colored. And you will see this blue color solution turning into red. That means that there is a positive test. That means that you have aliphatic aldehyde. Now, if you have aromatic aldehyde, that is that aldehyde group attached to a benzene ring, you do the same test. Okay, so will this occur? Will this happen or not? No. So this reaction will not occur, so you will not see the color change. Because if this reaction also occurs, how do I distinguish them? Since this reaction does not occur, I can say that if there is a positive test, that is an aliphatic aldehyde and not an aromatic aldehyde. If the test is not positive, then I can say it is an aromatic aldehyde. Are you with me? And you're going to do some knowns for this. So to see the color change, color difference. Now when you're given an unknown, you will be able to distinguish them. And you'll be able to identify what functional group you have in a given molecule. Again, how does this test distribute between them? You must watch the experiment video to find out. I did open the experimental video. Did you go through it? I opened it yesterday, I think. Yeah, over the weekend I opened it. Just in case some students are curious to watch the video, I just opened it. Anyways. So, look at that color change. Isn't that awesome blue? I like that blue. I don't like this as much. But, okay. When you compare this, that's a transparent nice blue. So this is the Bendix test. So this is you start off with. This is a negative test. The color of Bendix solution, which is copper sulfate blue, which is blue color, it's the same thing. It's not doing anything there. That tells you that it is not. If the test is negative, that tells you that it is not aliphatic aldehyde, isn't it? If there is aliphatic aldehyde, it will give you a positive test. That means that you should see red precipitate. So that tells you, if you see something like this with Bendix test, that tells you that is an aliphatic aldehyde. Are you with me? Positive test versus negative test. So now you identified whether the functional group is aldehyde. Now you identified whether the given aldehyde is aliphatic or aromatic. That's perfect. Again, the same question. And this keeps coming in, isn't it? So we should answer that question. I'm hoping that you will answer that question, at least by the end of this class. Let's see. Now the last one is iodoform test. This is a very typical test done in labs, and this is very fun, interesting. Now this iodoform test is based on, again, a chemical reaction, of course, and this is used to identify methyl ketones. Methyl ketones, specifically. What do you mean by methyl ketone? A ketone is a functional group where you have this carbonyl attached to two carbons. That's a ketone. But one of those carbons is a methyl. See, this is a CH3 group there. That is a methyl ketone. This can be anything else. But as long as it has a CH3CO, this structure there, CH3CO, that's a methyl ketone. So if you have a methyl ketone, this iodoform test will be positive. But if it is not a methyl ketone, this test will be negative. So iodoform test is to identify whether you have a methyl ketone or not. If you have methyl ketone, iodoform test will be positive. If the iodoform test is negative, that is telling you that there is no methyl ketone. It might be a ketone, but it's not a methyl ketone. So what happens here? Now how is this? Again, this is a color-based test. So at the end of the test, you will see this yellowish precipitate. We'll have some pictures saved. Now what happens in this reaction? There is a chemical reaction. Obviously, there's a mechanism for this. You treat this with base and iodine. So that's a sodium hydroxide and iodine. This base abstracts that proton, and then pushes those electrons and forms what is known as an enolate. This is a chemistry which we talk about in Organic 2 and in Chem 351 or Chem 350 also. At the later part of your class, you will touch this reaction. You will touch base with this reaction. If you're taking Chem 350, you will see that this enolate reactions are done. If you haven't covered that already, then you will cover them at some point, but briefly touched over. So, because those protons are acidic, the ones which are drawn here are acidic. So base abstracts that proton, grabs that proton. So base is going to grab that proton, push those electrons there, and which in turn pushes those electrons there. So you're pushing this bond there, forming a double bond, and you're pushing that electron there, so forming an O minus. That's how you get this. And this is known as an enolate. This is an enolate. Now what happens? Now this is going to react with your iodine in the reaction. It is going to push those electrons back, grab an iodine. So going from there to there, you have replaced a hydrogen with an iodine. And this process is repeated twice. Because this has, now remember this carbon still has 2 hydrogens. That is a methyl group. You had 3 hydrogens, you have replaced 1 hydrogen with iodine. These 2 steps are repeated 2 more times so that you replace all these 3 hydrogens on this carbon with iodine. And that's exactly what we are going to do. So you replace 1 other hydrogen. Repeat. You replace all the 3 hydrogens with iodine. That's what happens. Okay. Now once you get to this stage, you still have base. So that OH minus is now going to attack that carbonyl and eliminate this. This group comes out. See, that forms this intermediate, and then when you push this group comes out. And that is what forms your iodoform. This is known as iodoform, which is responsible for that yellow precipitate you see. So when you see that yellow precipitate, that tells you there is a methyl group on your ketone. That ketone C double bond O has a methyl group, because if you have this methyl group, it undergoes this reaction to give you that iodoform. CH3 comes from that methyl group. You're eliminating that methyl group completely from your ketone. And that is what is forming that iodoform. That tells you there is a methyl group there. And all you need to do is see that yellow precipitate there. So this grabs that proton to form this. And this is a salt, and then this is the precipitate which you see. So this is how you see that. So this is your negative test, nothing is happening. But if you see a precipitate which is yellow in color, then that shows that there is a methyl ketone. That is what we are looking for, a cloudy precipitate in the solution. If it's a clear solution, nothing there, it is not a methyl ketone. So make your observations carefully. When you're doing your known, if you carefully observe this, when you're doing your unknown, you'll be able to relate to it. So there we go. Sometimes when you drop these reagents, how you do them in the test tube matters. So the amount of quantity you take, sometimes you see false reactions. Oh, it looked like precipitate. Please be careful. When you're doing knowns, make your observations very clearly. That way when you're doing your unknowns, you can compare them accordingly. So just be very careful with your knowns. Let's say you have 3 unknowns. You have your unknown. It can be 1 unknown. So how do I identify? Where do I start? You start with, as we talked about, chromic acid test is the first thing I do. Because chromic acid tells me whether I have an aldehyde or not. Right? If the chromic acid test is positive, if it is positive, what does it tell me again? If the chromic acid test is positive, what does it tell me?
There's an aldehyde.
It's an aldehyde. Thank you. Perfect. So that tells me that it's an aldehyde. If the chromic acid test is negative, it can be a ketone or other functional groups, which I'm going to talk about in the next slide. But at least it's not an aldehyde. That I can confirm, isn't it? So chromic acid is negative, I can say it is not an aldehyde. Let's put it that way. It may be a ketone, we'll talk about it. So what do I do next? Now if it is a ketone, I can do an iodoform test to confirm whether it is a methyl ketone or not. Isn't it? So let's do iodoform, and then if it is a positive test, that tells me it is a methyl ketone. If it is not, then it tells me it is not a ketone. It might not be a ketone or a methyl ketone. So it's a process of elimination. It's not a methyl ketone. It might not be a ketone also. With me? Questions, concerns? So, now if it is an aldehyde, I would identify Bendix test. Why would I do this? To see if it is aliphatic or aromatic. So if it is a positive test, it is an aliphatic aldehyde. If it's a negative test, it tells you it's an aromatic aldehyde. Okay? So these tests are nicely lined up to give you what you are looking for, what your unknown might be. So again, what does this indicate? We already talked about all these things, right? The positive test with the Bendix and negative test with positive test with iodoform. Now with the chromic acid test, if it is negative, right? So the chromic acid is usually tested for all these groups, remember. So if chromic acid test is positive, we say it's an aldehyde. Chromic acid test is negative, it can be any of these functional groups. But you can eliminate aliphatic aldehyde, aromatic aldehyde Remember, these are all aldehydes. So how do I identify an aldehyde with aliphatic aldehyde and aromatic aldehyde? That is this test. So your unknown can be any of this. Step by step, you're putting them into these categories. So positive test, chromic acid positive, I would place aldehyde there. Now, Benedict's test, I would place aliphatic aldehyde here, aromatic aldehyde here, isn't it? Now, with the negative test, I would place ketone there. And then iodoform test, positive test would tell me it's a methyl ketone, and negative test, it would tell me this there. That is how the flow chart goes. Right? So again, you're taking the quiz next week. So you should know where to place what. Are we clear? Any questions, any concerns which I haven't addressed? The quiz is pretty much what we talked about in the recitations, what we have, what the calculations you did in the lab for your lab reports. It's not going to be any surprise. It's not going to be like, oh, we never looked into this. No, it will not be that way. It will be very simple, straightforward quiz. It's an open book quiz if it helps you. You can pull out your lab manual, you can pull out your whatever resource you want to Google it or whatever you want to do. Hopefully that will not kill your time, but you can do that. It's an open book quiz. We want you to score well, do well, but also follow the concepts. That's all we are hoping for. Let's see what else we have here. Now, remember, this is where we are. Again, as I mentioned, we are not going to meet next week. You are not going to come down here. So take a break. I'm sure you want a break, and there is a break. And after that, we have spring break again. Now, this is going to be a long break. When you come back from spring break, you do not have any recitation also. So we are going to meet the week of March 25th. Now that is a problem. After so many breaks, it's hard to remember we have a lab and we have to attend a recitation. I know, isn't it? Mark your calendars today. That way you don't forget. And I should also mark my calendar. I'm telling you, but I should go back and mark my calendar. March 25th, there's a recitation. I might sit in my office and I'm doing something else. Hopefully not. So please mark your calendars and take your quiz. It will be very much what you have seen and studied and heard before. Just relax, have a cup of coffee or water, whatever you drink, and then take your quiz wherever you are. Okay? That's a lab report to show you how to write it. This is more relatable for this week. So please go to that sample lab report. We have the first lab. Now this is the organic test. This is your carbonyls test. So unknowns, chromic acid test, positive, negative.